Okay, so what we're going to talk about now is we're going to talk about adding and subtracting radicals, and then we're going to talk about something called the conjugate. Okay, the conjugate piece is very important. It gets tested a lot on the Regents exam, usually 2 to 3 times, so it's really important that you guys know how to do that stuff. Okay, so what are like radicals? What do they have to have in common? Same index, same radicand. Good. Same index, same radicand. So an example of a like radical would be cube root of 3 and the cube root of 3, right? Or 2 square roots of 9. No, I don't want to use 9. That comes out pretty. We don't like pretty. 2 square roots of 7 and 7 square roots of 7. Those are all like radicals. Same index, same radicand. They can have different coefficients. That doesn't change them from being like radicals. Okay? Are you okay with that? I'm not sure. Can I make this go away? Okay, so, pardon me, 5 cube roots of x minus 3 cube roots of x. Any ideas? What? Awesome. 2 cube roots of x. So did I change the radicand? No. Did I change the index? No. What did I do? Subtracted what? The coefficients, right? Okay. So that's all I do for adding and subtracting. I just subtract those coefficients. Okay, so 4 radical 2 plus 5 radical 3? Can't do it. Why? Right, I don't have the same radicands. I do have the same indexes, not the same radicands. They can't be combined. Okay, so that just stays the way it is. Nothing. 2 radical 7 plus 3 radical 7. 5 radical 7. Good. Four radical xy plus 5 radical xy. 9 radical xy. Can't do it. Not like radicals. Okay? Okay. All right, so what happens when we don't have like radicals, but we still want to add or subtract? Okay? You have to look at the radicals you have. What do you notice about these ones? Yeah, they're all multiples of 2, which means they can be simplified, right? We can simplify those out, right? And when we simplify those out, the goal is to hopefully get like radicals so that we can add and subtract, okay? So how are we going to break down square root of 18? 9 and 2. And radical 8? 4 and 2. What are you noticing that they're having in common? 2. So chances are this is going to also have a 2. 36 and 2. Very good. Okay, so your goal is to kind of get that like radical if you can. We ready? I'll wait. Okay, square root of 9. 3. What do I have to do with the 3 and the 6? So it becomes 18 radical 2 plus radical 4. And what do I have to do? By what? And that becomes 8 radical 2. Oops. I did. Radical 4 is 2. 2 times 4 is 8. Radical 36. 6 times 3 is 'So I have 18 radical 2 plus 8 radical 2 minus 18 radical 2 gives me 8 radical 2. Yep, all have like radicals, so we add or subtract their coefficients. So you're just doing what we have been doing the past couple days. You're reducing those radicals to find like radicals, and then you're adding or subtracting. You okay with that? All right, so why don't you try B? I'm going to pause here, and we'll come back and go over it. Make this go away. Gabby, do you have that? Okay. Talk. Okay. How am I going to break down square root of 50, guys? 25 and 2. Very good. And 32. 16 and 2. You guys are so smart. And 18. 9 and 2. Awesome. Okay. Square root of 25. Square root of 2. Plus square root of 16. What do I do with the 4 and the 3? 12. Square root of 2. Minus square root of 9. 3 and 15, or 5. I always say the answer when I'm trying to ask the question. 5 times 3 is negative 15. Square root of 2. Okay. 5 plus 12 minus 15. 2 radical 2. Excellent job. Okay. How do we feel about those? Pretty good? Comfortable? No radicals, just exponents on the quiz tomorrow. Ready, guys? Huh? Exponents tomorrow. Like our quick quiz today. Okay, so we're going to continue with multiplying radicals. Now, sometimes we have radicals in binomial form. Binomial meaning 2 terms, okay? So if I have 3 plus 2 radical 5 times 2 plus 4 radical 5, how do I multiply together 2 binomials? I FOIL them. Excellent. Okay? And we know how to multiply radicals, so this shouldn't be difficult. Okay? So FOIL, first terms, are going to be 3 times 2, which gives us 6. Outer, 3 times 4 radical 5. No. Good. It'll give you a decimal, and you don't want that. No. Inner. Good. 4 radical 5. And last.
8 radical 5.
8 radical 25. Right? When we multiply radicals, you have to multiply the radicands. Okay? Pardon me. It wouldn't be radical 5. What's the square root of 25? 5. Okay, so here's the hint. Whenever you multiply a radical by itself, you always wind up with the radicand. Always. Okay, so if I had square root of 3 times square root of 3, it's going to be 3. Okay, so do I need to write 25? What am I going to write? 5. Okay, 8 times 5 is 40. Okay, so what should I do now? Add what? Like terms, thank you. So I have 6 and 40, which is going to give me 46, right? This is 40. And I have 12 radical 5 and 4 radical 5. And there's your product. Okay? Can I combine those? No, because does the first one have a radical? No. Okay, they're not like terms, so I can't combine them. So that's my product, okay? And you do want to usually write it with that constant before the radical. That's just kind of generally how they normally get set up. They can be written the other way, but generally speaking, we like them to look like this, okay? What does that squared on the outside mean, guys? Only if you want me to stomp on your foot. Good, I have to multiply the whole thing by itself, okay? That's squared. You cannot. This does not equal this. No. Okay? The squared means you're multiplying it by itself, just like x squared means x times x. We know that, right? So that's exactly what's going to happen here. Square root of 2 minus square root of 3 times square root of 2 minus the square root of 3. So again, how do we multiply together two binomials? We FOIL it. So go ahead, FOIL that out, and we'll go over it in a moment. Okay, square root of 2 times square root of 2, guys. 2. Square root of 2 times negative square root of 3. Good, negative radical 6. Negative radical 3 times positive radical 2. Negative radical 6. Yes, it's a minus sign. Negative radical 3 times negative radical 3? Plus 3. Okay. Combine my like terms. 2 plus 3 is 5. Very good. And negative radical 6 minus radical 6. No. You're all wrong. Negative 2 radical 6. Negative 1 minus 1. What does that equal? You guys are killing me with the negative numbers. Negative 2. You understand? If I owe Joe $1 and then he gives me another $1, how much do I owe him? $2. That's right. I hope so, guys. I'm fretting. Okay, so really important concept. Conjugate. Okay? We have to learn to deal with the conjugate because we cannot have radicals in the denominator of a fraction. It's a big no-no. Okay? So we have to learn how to do something called rationalizing. And in order to rationalize, we need to know the conjugate. All right? So, two different kinds of conjugates here. If I have radical 3, the conjugate of radical 3 is just going to be radical 3. I know. Hold on. If I have 2 minus radical 2, the conjugate of 2 minus radical 2 is 2 plus radical 2. What did I change? What sign? Just the center sign, the sign in the middle. Did I change anything else? No. Okay, so if I give you negative 1 plus radical 5, what's the conjugate? Okay, do you see how we get the conjugate? Difficult? Just have to remember to change that middle sign. That's all we're doing, okay? So negative 7 minus radical 2, what's the conjugate? Plus radical 2. Okay, just changing that center sign. Good? There's something interesting that happens when we multiply something by its own conjugate. Okay? And we're going to find out what that is. So I've got 2 plus radical 3 times 2 minus radical 3. Conjugates, right? So how do I multiply together two binomials? I FOIL. Okay. So I want you to FOIL these out, and I want you to tell me what happens. Okay, I'm going to pause here. 2 times 2. 4. 2 times negative radical 3? Good, negative 2 radical 3. Positive square root of 3 times 2. And positive radical 3 times a negative radical 3. Minus 3. Good. What happens in the middle? Yeah, negative 2 radical 3 and positive 2 radical 3 cancel out. Do I have any more radicals left? That's kind of the goal of the conjugate, to get rid of radicals, okay? 4 minus 3 is? Okay. So this is important because when we want to go and rationalize a denominator or get rid of a radical in the denominator, we use the conjugate. Conjugate's going to get rid of all the radicals for us, okay? So do I have to go through and FOIL that whole thing out every time I multiply by the conjugate? No, I only have to do first and last, because I know if I'm multiplying by the conjugate, the middle terms are going to cancel. Less work, right? Okay, so next page. Let's look at this first one. Okay, so big no-no, cannot have a radical in the denominator. Can't have it. So I need to do what's called rationalizing. Okay? The way we rationalize is to multiply by the conjugate of the denominator. But here's our issue. We don't want to change the value of that fraction. Okay, if I were to put that in my calculator, it would actually be a value, right? A number. I don't want to change that. So what could I multiply by that won't change it? What can I multiply anything by that won't change it? 1. But the goal is to get rid of the radical. So I have to multiply by the conjugate in the denominator, right? But since I want to be multiplying by 1 so I don't change the value, what do I have to multiply the numerator by? Same thing. Okay? Anything over itself is 1. All right, so in order to rationalize the denominator, I'm multiplying by the conjugate of the denominator in both the numerator and the denominator. Okay? How do I multiply together two fractions? Straight across, right? Numerator by numerator, denominator by denominator. Please explain to me when we cross multiply. When there's an equal sign. Okay, like 2x over 3 equals 7 over 4. Then we would cross multiply. Got it? Okay. All right, so numerators, how am I going to have to multiply those? How? FOIL. Got a FOIL. Now, that's denominator, right? Because this isn't the numerator's conjugate. So you can't just do first and last. You have to do the whole thing. All right? In the denominator, I'm multiplying by the conjugate. So that one I only have to do first and last. Okay? So, numerator. 3 times 1. 3 times positive radical 5. Good. 1 times positive radical 5. No. And radical 5 times radical 5. Just 5, right? So plus 5. Okay, so there's my numerator. Are you okay with the foiling part? Yes? Okay. Denominator, we're multiplying by the conjugate, so which 2 do I have to do? First and last. Okay, so first is 1 times 1. Last is negative radical 5 times positive radical 5. Negative 5. I'm going to get that constant back, which is what I want. Don't want any radicals. Numerator, I do what? And what do I get when I combine like terms? 8. That's okay. Plus 4 radical 5 over negative 4. Am I done? What can I do? I can divide, yeah. Now, when I'm dividing, do I just divide into one part in the numerator? Or do I divide into both? I got to divide into both, okay? If you're going to simplify, make sure it gets simplified into both pieces. I'm sure, okay. If it doesn't, it stays. Okay, if it doesn't divide into both pieces, it stays. Okay, 8 radical negative 4, 8 divided by negative 4, negative 2, and 4 divided by negative 4. So I get negative 2 minus radical 5. Okay, it's got to be simplified into both pieces in order to simplify. Are we okay? These are really important. These always show up at least 2 problems on the Regents. At least, okay? Got to know how to do this. Now, if I had something like 2 over radical 3, what's the conjugate of radical 3? Radical 3. So I'm just multiplying by itself, okay? This becomes 2 radical 3 over 3.
So whatever the denominator is,
That's it.
always the same.
And if it's a binomial, you switch that center sign, right? Okay, so try the next one, and then we'll go over it. By the way, before I run out of time and forget, your homework tonight is pages 8 and 9 in that packet. Okay, and it's all of this stuff. It's pages 8 and 9. All right, so try B, and we'll go over it. Guys, I want to go over this before we're out of time. What's conjugate? Four plus radical 15. Okay, so numerator. Right? Do we all get that conjugate right?
Yeah.
Okay, so we FOIL in the numerator. 6 times 4, 24, yep. Good. Good. Good, excellent. How'd you guys do with that? Excellent. All right, denominator, what do I have to multiply? First and last. First is going to be 16, 4 times 4. Last? Good, minus 15. Combine like terms in the numerator. Excellent. And denominator? Done. That doesn't simplify. Okay? You don't have to write the one, it's not necessary. If you want to, it's fine. Okay? All right, so again, homework is pages 8 and 9. You have a quiz tomorrow on exponents. I will be after school until 3 o'clock. At 3 o'clock, I have a conference on the computer. So I can help you till then, okay?